So in this video, I want to explain the different types of loads. The first one is the concentrated load, as we can see in the first figure. So it is called as concentrated load or point load. Now in this beam, the beam is supported at A by an hinge support and by a roller support at point B. Now this beam is loaded with a point load of intensity 10 kilonewton. Point load or concentrated load always represented with an arrow, and the unit is kilonewton. The unit is kilonewton. The second type of load is uniformly distributed load. The short form for that one is uniformly distributed load is UDL, uniformly distributed load. Now we can see in this figure, again the beam is supported at A by an hinge and B by roller support, and uniformly distributed load is represented like this, and the unit we can clearly note that it is kilonewton meter. Now the beam is having a span of 6 meter and loaded with an intensity of 10 kilonewton per meter, or it is also represented like this. It can be represented in both the ways, either as it is shown in the left figure or it is in the right figure. Now one more concept I want to explain here. Any type of load can be converted into an point load. So now the below diagram, below this one, I have shown the conversion of UDL to point load. How the UDL load can be converted into point load. Now we can see here I have written a dotted line, that is 10 kilonewton per meter into the 6. 6 is the span through which the load is acting. If you do that one, the load will be converted into a point load. 10 into 6 is 60 kilonewton, that where it will act exactly at the center, that is 3 meter from left support and 3 meter from right support. So since it is 10 kilonewton per meter into 6 meter, meter will get cancelled, so it will be left with 60 kilonewton is the intensity. That is the conversion of UDL into an point load. Then one more type of load is there, that is uniformly varying load. Uniformly varying load. The short form is UVL. The difference between UDL and UVL, that is the difference between UDL and UVL, now I will explain. Now see here, in UVL the intensity is completely zero at the left support and it rises linearly and attains a maximum value of 20 kilonewton per meter. But UDL, the intensity is constant throughout the length of the beam. That is the major difference between UDL and UVL. Both is having kilonewton per meter is the unit, but the difference between UDL and UVL is the intensity is constant throughout the beam, but the intensity varies linearly in case of uniformly distributed load. Uniformly distributed load is also called as triangular load. It is also called as triangular load because the load looks like a triangle. Now the beam is supported at A by an hinge and by roller at point B, and it is loaded with uniformly varying load. It is also called as triangular load. Again, this uniformly varying load can be converted into a point load. How we can do? I have just demonstrated here. The area of a triangle, the area of the triangle is half into base into height. Now if I take this triangle, half, what is the base of the triangle is 6, the height of the triangle is 20 kilonewton per meter. So if I simplify, it will be equal to 60 kilonewton. Now where this 60 kilonewton point load will act, this is acting at a distance of 2/3 of 6. 2/3 of 6 is nothing but 4 meter from the lowest intensity point. So from here it is 2/3 of 6. This is 2/3 of 6. That will be equal to 4 meter. That is from the lowest intensity point. From the highest intensity point, from this end, it is 1/3 of 6. It is this distance will come to 1/3 of 6, that will be equal to 2 meter. That will be equal to 2 meter. That means this point load will act at a distance of 2/3 of 6 from the lowest intensity point and 1/3 of 6 from the highest intensity point. Next type of load is trapezoidal load. Trapezoidal load, as we can see in the diagram, it is called as trapezoidal load. Here in trapezoidal load, the intensities are linearly varying, but it is not completely zero at the other end. As we can see here, it is having an intensity of 10 kilonewton per meter at the right, and at the left end it is 20 kilonewton per meter, acting through a span of 6 meters. In uniformly varying load, the intensity will be completely zero. That is UVL. I hope you are getting this point. Trapezoidal load, the intensity is not zero. It is having some intensity, but in UVL it will be completely zero. Now again, this UVL can be converted into an point load. How we can do? I've just demonstrated here. The left end 20 is the intensity, right end 10 is the intensity, so it is 20 plus 10 divided by 2 into 6 is the span through it is acting, so it is 90 kilonewton. So the formula will go like this: W1 plus W2 divided by 2 into L. W1 is 20, W2 is 10 divided by 2 into span through it is acting is 6, so it is 90 kilonewton. Similarly, now where this point load will act, that is the distance x. X can be calculated by using the formula W1 plus 2W2 divided by W1 plus W2 into L by 3. In place of W1 we have 20. In place of W2 we have 10. Substitute in the formula, we will get the value of x as 2.67 meters. Then this y will be nothing but L minus of x. L is 6, that is the span of the beam, into x. L minus of x is 2.33 meter. Like this we can convert trapezoidal load into a point load. Thank you.